Start, sir.
Hello and welcome to the second live session for the NPTEL course on GPU architectures and programming. So we'll be clearing possible doubts which may be posted in the forum. So right now I have one doubt already posted. So let me just have a look into it. So Prajyot Chandrasekhar, he has a question on when using CUDA C++, will the class default destructor called CUDA free for the memory allocated inside the constructor using CUDA malloc automatically? Or do I have to overload the destructor to call CUDA free, and is it safe? So I'm not sure I correctly understand what you mean by overloading the destructor here. But just to make it clear, anytime you are allocating memory to any object using CUDA malloc, you have to be doing the memory management explicitly as a programmer. That means the moment you feel that that object is no longer necessary for you, you should be doing an explicit CUDA free for the same. Okay, so we'll be waiting here for any further questions if anybody has any questions. So if you have any query, please post. Otherwise, we think we won't need any more time in this session. And I guess there had been queries earlier in the forum, which we have already tried to answer. Okay, I don't think we have any more queries. So Okay, we now have a request about some assignment question. So give us a minute, we'll dig them out. And 1 minute. Okay, so this question is, let me just read out the question first for all. So consider the following. I'm reading out question 5 of assignment 6. So consider the following code snippet executing on a GPU architecture where you have shared memory divided into 32 into 32 banks, and each bank is of width 4 byte. Okay, and so, well, we are reading the rows and you have these shared tiles. Mm, Now, as you can see in the question body, these thread IDs have been left open, right? Now, you have the kernel whose launch parameters are specified, right? So you have 32 cross 32 blocks, and and you have 32 cross 32 number of such blocks, each containing an 2D arrangement of 32 cross 32 threads. Now consider the last shared operation. The accesses for this operation depends on the values of TI, DX, and Y. So as you can see at the last, you have this out GID, right? So you are computing the global ID, and then you are just loading the value from the tile. So all you are doing is you are writing the global ID here, right? If you look into the code, so you have defined this tile of size SZ, that is 32 cross 32, in the shared memory, right? And this is the tile that has been defined. And so you first have a write operation happening into the shared memory. So basically the global ID, that's the mapping of the value of the global ID, gets written to each corresponding location of the tile by all the threads in parallel, right? And then you again have this TID values. They are getting, I mean, they are local thread IDs in X and Y dimension. This TIDX and TIDY, these are the local variables for each thread, right? And then accordingly, you are just writing back in the out matrix, out GID, in its location, you are just writing back the data. Now the question is whether, yeah, so the question that you have is, if I assume these TIDX and TIDY values to be equal to the local thread IDs. I mean they are but in a reverse manner actually, as you can see. So you have TIDX. Uh, 1 minute. Where did the question go out? Just a minute. Yeah, sorry. So TIDX equal to thread ID x dot y, right? So now when you are trying to write, so you see what is happening when you are doing the reads to the shared memory. You have you have a read in the standard order, right? Because you are defining the tiles in the x and y dimension, right? So tile thread id x dot x and thread id x dot y, right? So if you consider a thread inside a block, right? And so let's say their values are like I mean thread id x dot x and y values are like 0 comma 1 1, I mean followed by let's say 0 comma 2 and all that. So they are all writing sequential in the rows, right? Now the writes, when they are happening in the in a kind of switched version, because if you see TIDX, now TIDX is containing the y coordinate and the TIDY is containing the x coordinate. So that's how it's like having the transpose happening through the shared memory, right? And the question is whether the shared load of the transactions are bank conflict free, right? So if you look at the shared loads, uh, let's just understand how they are really happening. So for each of the threads which are inside a warp, try and figure out what are the values of TIDXs, right? So essentially you have consecutive thread IDs, right? So inside a 32 sized warp, you have threads, and for those threads, what's really going to change? So you will essentially have their thread ID x dot x as same, and their thread ID x dot y values will be consecutively increasing, right? Now, since that y value will be consecutively increasing, and that will be right, I mean, in the TID in this style, it is basically the second index. So the second index bits, if I think of this tile in the shared memory as a 2D matrix, we are just considering that I mean, on this warp is kind of loading one column of the 2D matrix, right? So, and those values are going to be, since we have assumed that it's a 32 bank sized shared memory, those values are going to lie in all the different 32 banks, right? So naturally, these load transactions are going to be conflict free. So the correct answer in this case would be true. So like as we said, if you consider warp 0, these values, these loads are going to be happening with locations from like 0, 0, 0, 1, 0, 2 like that up to 0, 31, right? And warp 1, 1, 0, 1, 1 like that. So it's like the zeroth, I mean, if I consider the zeroth column, then the first column, then the second column, all of them are getting loaded from the shared memory by zeroth warp, first warp, second warp, like that, right? So naturally, all of them are going to be conflict free. So then the next question in that assignment, uh, it's uh, it's on this for the code snippet in question 5. So it refers to the previous question only. State whether the following statement is true or false. So what is that? So for thread ID x equal to thread ID x dot x and TID y equal to thread ID x dot y, shared load transactions are blank conflict free. Now, so essentially now we are saying that suppose in the previous question, we if you see we have switched the TIDX and to a DY with their I mean intuitively opposite values. Basically, we made TIDX as thread IDX dot y, right? But now we are saying that let's consider TIDX as thread IDX dot x, right? So do I have conflicts in this case? I mean, so the question is, it's a statement that is conflict free, but no, in this case you will have conflict, so the answer would be false. Why? You will just see that if I mean it's just the opposite thing, right? So in this case, you will have elements coming from the same bank, right? So each warp essentially accesses a column of the matrix which is mapped to the same bank. So in this case, it will be, I mean, if you look into the thread IDs, just a minute. So in the previous case, as you can see, it's all 0001 like that. So they are all going to be in consecutive locations, right? So consecutive locations in this tile, right? And that makes them all distributed across the different banks. But in this case, they are all going to be in the in all of them are going to be mapped to the same bank, because if you just think of what would be the IDs that the warp 0 will be loading, the IDs that the warp 0 will be loading are like 01, sorry, 00, then 10, then 20, in this way up to 310, right? So all these values will be in the zeroth uh, zeroth bank, right? In that way, in this case, all of the loads inside the warp are going to have a heavy conflict, and that's going to be problematic. So you are going to have, I mean, significant amount of delay in this case. So just correct me from a problem here. So I think when I answered the previous question, I may have accidentally mentioned that your warp 0 is loading one column from the matrix. Sorry, it should be, it's loading one row from the matrix. But the point I was trying to make is, well, the row is all distributed. The row is all distributed across all the banks because they are all consecutive locations. So there won't be any conflict in that case. But in this case, when we are considering tidx equal to thread idx dot x, tidy equal to thread idx dot y, in this case, you will be having the conflict, because as you can understand that, well, uh, you are going to have all of those values mapped to the single column, and that's going to create a problem. And I mean, because they are all, essentially you have all the loads that one warp is demanding, all the loads are going to happen from a single bank in the shared memory, and that's going to be a problem. So I hope that answers your question. So just to add to the so I see somebody is asking, I am unable to understand how to identify whether a row is being accessed or a column is being accessed based on thread ID X and thread ID Y values. I mean, it's very simple. Like, see, I mean, if you look into our teaching material, one thing we make clear, right? So, suppose you are looking at how the warps are working. So, threads are getting packed in the warp in a very nice way. So, let's say warp 0. If you look into the local thread ID values, so for warp 0, I'm considering in 2 dimension, right? So in 2 dimension, if I write that in warp 0, which are the threads that are there? So I have thread idx dot y comma thread idx dot x values. Okay, and for warp 0, thread idx dot y equal to 0, and thread idx dot x value is increasing from 0 up to 31. Okay, so that's warp 0. Don't think it in a standard way like x is coming first and y is going next, right? So that's the mistake people may often make. If it is in three dimension, if you look into a material, then also you will see that first the z dimension will come, thread id x dot z, then dot y, then dot x. Okay, so in that way it will come. So that is why uh, if you are using warp 0, then what is really constant in this case is your thread idx dot y, right? And thread idx dot x is changing. Now if you are making, if I refer back to question 5, everything depends on the access expression. Look at the access expression when you are doing the load. Okay, so your access expression is style tidx tidy. Okay, now as we said that in this case what is happening, uh, you have this tidy value, right? In every warp, what is the case here? The value of thread idx change for a fixed value of thread id y, right? So you have this tidx. Tidx is nothing but thread idx dot y, because remember in this question, the previous first question, it is switched, right? So tidx is actually thread idx dot y, which is not changing, right? And tidy is actually thread idx dot x, which is changing for the threads inside a single warp. Now, what happens in a 2D matrix when the first element, when the first index doesn't change, but the second index changes consecutively? Well, you are picking up elements from the same row. That's exactly what is happening. So you are accessing consecutive locations inside a 2D matrix, right? And those consecutive locations will naturally map to different, consecutive banks in the shared memory, and that is kind of resolving the conflict here. So maybe you got this question wrong because you may have forgotten the situation, like I'm saying, that when you think, when you think that how threads are getting packed inside a warp, it's always sequentially, and inside the sequential thread ID values, it's the z coordinate, then the y coordinate, then the x coordinate, right? So in any warp you will have, assuming that the dimension are more than or equal to 32, that would mean while the z and the y coordinate will remain fixed and the x coordinate is going to increase, right? So that's what is happening here. The x coordinate is increasing. Now when you are looking into, and the y coordinate is fixed, and in this case in the access expression you see out gid equal to tile tidx then tidy. tidx is thread idx dot y, which is fixed. Tidy is the thread idx dot x, which is changing inside a single warp, right? So you have the row getting loaded, and the row is in consecutive shared memory banks, so there is no conflict. As simple as that. I hope now it is clear to you, Abhishek. So maybe it will be a good idea if you try some more access expressions by yourself and simply map things to the memory accesses and see that whether what is really happening in a consecutive manner. Okay, there is a question. I have more interest in the architecture design of GPUs. Will more details be discussed in future sessions with respect to design aspects? Well, unfortunately, in this course, in the later parts, we'll focus more on the programming parts. But definitely, GPU architectures are really interesting, and we have several advanced topics related to that. One thing that you will see that we'll be discussing architecture specific optimizations, which naturally will require some background of architecture of GPUs. But that much background will be more about what things that we have already discussed. And beyond that, there are architectural aspects of GPUs like design of hardware schedulers and how to make the code secure and all that. If you are interested in those topics, please contact us. We'll provide you more material on that. But right now, what we have more in the course is related to architecture aware optimizations. Okay, if there are no more questions, then maybe we can close the session.
We can end the session now, sir.
Okay, thank you. Bye.